everyone, myself Naveen. I am pursuing my second year MSc in Manasangagotri, Mysore. Now I am presenting my seminar topic Ensemble Learning, Boosting and Bagging. Now let us see what is an ensemble method. Ensemble is a machine learning concept in which the idea is to train multiple models using the same learning algorithm. The ensembles take part in a bigger group of methods called multi-classifiers, where a set of hundreds or thousands of learners with a common object are fused together to solve the problems. The second group of multi-classifier contain the hybrid methods. They use a set of learners too, but they can be trained using different learning techniques. Stacking is the most well known. Bagging. Bagging stands for bootstrap aggregating is a way to decrease the variance of your prediction by generating additional data for training from your original dataset using combination with repetitions to produce multi-set of the same cardinality or size as your original data. By increasing the size of your training set, you cannot improve the model predictive force, but just decreasing the variance narrowly, tuning the prediction to expected outcome. Random forest. The random forest approach is a bagging method where deep trees fitted on bootstrap samples are combined to produce an output with lower variance. However, random forest also use another trick to make the multiple fitted trees a bit less correlated with each other. When growing these trees, instead of only sampling over the observation is the dataset to generate a bootstrap sample. We also sample over futures and keep only a random subset of them to build a tree. We can see the diagram where random forest method is bagging method with trees as weak learners. Each tree is fitted on a bootstrap sample considering only a subset of various randomly. Boosting is a two-step approach where one first uses subsets of the original data to produce a series of averagely performing models and then boost their performance by combining them together using a particular cost function equal majority vote. Unlike bagging, in the classical boosting, the subset creation is not random and depends upon the performance of the previous models. Every new subset contains the element that were likely to be classified by previous model. Adaptive boosting, often called ADA boost. In adaptive boosting, we try to define our ensemble model as a weighted sum of L weak learners. In this diagram, we can see ADA boost updates weighted of the observation at each iteration. Weights of well-classified observation decreases relatively to weight of misclassified observation models that perform better have higher weight in the final ensemble model. Bagging and boosting are both ensemble methods in machine learning, but what's the key behind them? Bagging and boosting are similar in that they are both ensemble techniques, where a set of weak learners are combined to create a strong learner that obtains better performance than a single one. So let's start from the beginning. The main cause of error in learning are due to noise, bias and variance. Ensemble helps to minimize this factor. These methods are designed to improve the stability and accuracy of machine learning algorithms. Combination of multiple classifier decrease variance especially in the case of unstable classifier and may produce a more reliable classification than a single classifier. To use bagging or boosting, we must select a base learner algorithm. For example, we choose a classification tree. Bagging and boosting would consist of a pool of trees as big as we want. In this diagram, you can see single bagging and boosting. In single, we have one learner. In bagging, we have n learners, and boosting also we have n learners. How do bagging and boosting get n learners? Bagging and boosting get n learners by generating additional data in the training stage. N new training data set are produced by random sampling with replacement from the original set. By sampling with replacement, some observation may be repeated in each new training data set. In the case of bagging, any element has the same probability to appear in a new data set. However, for boosting, the observations are weighted and therefore some of them will take part in a new set more of diagram shows how single bagging and boosting are divided. Complete training set, random sampling with replacement, random sampling with replacement over weighted data. These multiple sets are used to train the same learner algorithm and therefore different classifiers are produced. Why are the data element weighted? At this point, we begin to deal with the main difference between the two methods. While the training stage is parallel for bagging, therefore each model is built independently. Boosting builds the new learner in a sequential way. Single bagging and boosting. In single we have iteration, in bagging we have parallel, in boosting we have sequential. In boosting algorithm, each classifier is trained one data, taking into account the previous classifier success. After each training step, the weight are redistributed. My classified data increase its weight to emphasize the most difficult case. In this way, subsequent learners will focus on them during their training. How does the classification stage work? To predict the class of new data, we only need to apply n learner to the new observation. In bagging, the result is obtained by averaging the response of the n learners or majority vote. However, boosting assigns a second set of weights, this time for n classifier, in order to take weighted average of their estimates. Diagram in single bagging and boosting. We have single estimate, simple average, and weighted average. In the boosting training stage, the algorithm allocates weights to each resulting model. A learner with good classifier result on the training data will be assigned a higher weighted than a poor one. So when evaluating a new learner, boosting needs to keep track of learner error too. Let's see the difference in the procedure. Single bagging and boosting. In single we have train and keep. In bagging we have train and keep. In boosting we have train and evaluate. Some of the boosting techniques include an extra condition to keep or discard a single learner. For example, in ADA boost, the most renowned an error less than 50% is required to maintain the model. Otherwise, the iteration is repeated until achieving a learner better than a random guess. The previous image shows the general process of boosting method, but several alternatives exist with different ways to determine the weight to use in the next training step. In the classification stage, click here if like to go into details. ADA boost, LP boost, XG boost, gradient boost, Brown. Which is the best, bagging or boosting? There is not an outright winner. It depends on the data, the stimulation, and the circumference. Bagging and boosting decrease the variance of your single estimate as they combine several estimates from different models, so that result may be model with higher stability. If the problem is that the single model gets a very low performance, bagging will rarely get a better base. However, boosting could generate a combined model with lower errors as it optimizes the advantages and reduce pitfalls of the single model. By contrast, if the difficulty of single model is overfitting, then bagging is the best option. Boosting for its part does not help to avoid overfitting. In fact, this technique is faced with this problem itself. For this reason, bagging is effective more than the boosting. Thank you everyone.